All right, hello again. This is Jeff Scott of Blackhawk Technical College. Right now, I'll be going over the three problems that were assigned for Homework 2 for the 152-148 Relational Database Coding, also known as PHP class. All right, so I'm going to do these a little bit out of order, and I'll try to explain why I'm going to do these a little bit out of order in just a second. But I'm going to get onto the virtual desktop here, okay? Number one was the guessing game. We're going to do that one last, and I'll explain why in a bit. Number two was a prime number program. Okay, so the idea was we were supposed to read in a beginning number and an ending number and show all the prime numbers that were within that range. Okay, now I didn't do it exactly like the stuff here asked. So what I'm going to expect is that if you want to be able to get as many points as you possibly can for the assignment, yes, you can use my stuff here as a starting point, but you'll add the stuff on it, all right? So you'll meet all the requirements that are here. So why am I doing number two and then number three? Well, what ended up happening was number two and number three are very similar to one another. So I ended up using the same CSS file for both number two and number three. So let's take a look at that. All right, I set the font family, and I've got a content area that I made 450 pixels wide. You can see with the margin and the padding, etc. There's an H1 tag that's navy at the top. I made the labels a certain size. I made my buttons a certain size, and I set it up so that if there was an error, it put it in there in red. So I'll tell you what I'll do is I'm going to literally make a copy of this main.css file and put that out there on the system. And in just a second, I'm going to show you my index.php file, my display results.php file, my functions.php file. But first, let me start up XAMPP, and I'm going to run this for you. And I'll show you what mine looks like. Sorry, I had XAMPP up and running before. For some reason, I got kicked off of the virtual desktop and everything basically just shut down. And that's okay. All right, so I'm going to come in here and do my http://localhost/hw2. All right, so right now we're under the prime number program. So here's my interface. Just so you see this, there's the interface for the prime number program. Next, we're going to go over the leap year. Look familiar? All right, so the interface basically between these two is almost identical. Now for the guessing game, the interface looks the same here, but it actually isn't, okay? And I'll explain that in just a bit. So here's the the prime number program. So for instance, I put in 1 here for my start number. I put in 100 here for my stop number, all right? And I click calculate. Now notice what it shows me. First it shows me, it says here prime numbers, so it shows me an array. These are all the prime numbers between 1 and 100. 2, 3, 5, 7, 11, etc. All right, so it looks like there's 25 of them. Here are the non-prime numbers, and I gauged 1 as being non-prime because it said in there that it wasn't. So you'll notice in here we've got 75 that are not prime. Okay? So what I want to do is, again, I will save this file, this CSS file, and I will put it out there on the system. So if you want to use that, you'll be able to. By no means do you have to use that. All right? So let's take it from the top. I was going to take the time and rebuild all these for you, but you know it just takes quite a bit of time. So I've got a file in here that's called functions.php that I'm including. I'll show you that in just a second, but that's at the top of my file. Then I've got the comment for all the program stuff, and that's about 25 or 30 lines. Okay? So the actual file right here, and I'll leave this up here, but if you're going to take the time to do this second assignment, then you're going to have to watch this tape, pause it so you can type in this stuff, type in a little bit, pause it, type in a little bit more, pause it, etc. All right, so here's my title that'll appear in the status bar. Here's my link to my CSS file that I just showed you. So that's what's in the head section. All right? Jumping down to the body. I put a div around the whole thing. It says div content. There's the end of the div. All right? So what this is doing right here, this stuff that's in here, is that is building this. All right? So that is the index.php file. In fact, if I literally type in index.php, you'll notice it looks exactly the same because it is the same file. All right. So what are we doing here? Well, there's the H1 tag, prime number program number 2. So that's this. Okay, nothing surprising right there. All right. Then I said here, if I had any error messages, print those out. What does that mean? Well, let's suppose that I try to run this program and I don't have anything in here. There's the error messages. Start number must be a number. Stop number must be a number. And I believe that our limits over here were 1 in 10,000. So if I put -2 and I put in here for the next one, -2. All right. Then notice the errors that I get. Start number must be greater than or equal to 1 and less than or equal to 10,000. Stop number must be greater than or equal to 1 and less than or equal to 10,000. Now notice here I literally said the word start number and stop number, but if you put nothing in there, I said that, which doesn't, So what I could do if I wanted to is I can go in here and I can change my start number and stop number with what I said in there. So as soon as I find that, let's see. Error message. Somewhere that's being set. So right there I said stop number, and here I said stop number like that. So I really should be consistent. That's all I'm telling you. So that should say stop number like that one does. And the start number should be the same thing. So this should say capital S start number just like that one does. So did I buy myself anything? No, I wasted a little of your time. But notice now that it says start number and stop number. Okay, so I'm a little bit more consistent. All right, let's go back and look at the code now. All right, so taking it from the index page. Comment at the top, I included once this functions.php file, which we'll talk about in a minute. It's actually a very short file. All right, so then in our body, here's our H1 tag. Then I said if there were any messages, so in other words, this variable that I've got that's called error message, if it's not empty, then echo it out on the screen. That means if there are any error messages, show them. Don't go on, don't do any more. Just show the error messages. All right? If I put in valid numbers, then I want to call display results.php, which is what we'll look at next. So here I'm building the form. That should be pretty obvious to you. And what does this say? Well, this says if the start number is set, put that number in there. Otherwise, put in nothing. And this says the same exact thing with the stop number. If there is a number in there, show it. Otherwise, don't show it. So what the heck does all that mean? First of all, again, there's my include once functions.php file. So I'll leave that up there. Then I had about 20 lines of comments. Then here's the beginning of the index.php file. I'll leave that up there for a minute. Going up to the top of the form here. So here's part of the form. So there's creating all the stuff for the start number. And literally then, everything that's in here, right there, could be copied from here and placed down in here and just change start number to stop number. All right? And then there's the button on the bottom that says submit and calculate. So that's everything. That's that whole program. All right? So if it all works, we call display results. You notice that's about 100 lines or so. All right, so what do we have in there? Well, at the top, again, the first 25 lines is the comment explaining what the program's about. So I'm going to skip that, of course. I again included our functions.php, which I'm going to go over in a minute. This line right here, remember what this line here, line 31, means. That means if we clicked the submit button, because if we click the submit button, then what we're doing is we're posting. All right, let me shrink this down just a tad so you can see all of it. There. All right, so in other words, if I have put numbers in here, or at least if I've clicked that calculate button to figure out my primes, then I want to set start number equal to whatever was in the form. I want to set stop number to whatever was in the form. So in other words, start number and stop number that you see right there are going to be equal to whatever I put in here and whatever I put in here. So that's start number, that's stop number. All right. Here's my other program variables. I've got that variable that's going to hold any possible error messages. All right, and what I'm going to do is I'm going to have this thing called valid range that I'm going to use twice, so I just made it a variable that says must be greater than or equal to 1 and less than or equal to 10,000. Okay? Here's a temporary variable. The way that I set this up, just so you see it, let me run it again and just show you exactly what I'm about to tell you here. Now, you saw this already. If I put in 1 and if I put in 100, everything's hunky-dory. All right? It shows me the primes, it shows me the non-primes. Not a problem. I could do something similar if I put in 1 and 1,000. But what if I put in this? What if I put in 250 and 10? Well, the start number is now greater than the stop number. So I had a variable that was called temp, and I said check, and if the start number is greater than the stop number, flip them. So notice when I click calculate, it goes from 10 to 250, not from 250 to 10. All right, so there's 10 to 250. Notice there are my primes. All right, there are my non-primes. Okay, so the reason I'm showing you that is that's what that temp variable right there is for, in case I have to flip the two numbers. Here's my array that will hold the primes. Here's my array that will hold the non-primes. Here are the constants. I told you to use constants if possible. So that's min number is 1 and max number is 10,000. Well, then I had to validate the start number. If for some reason it wasn't numeric, then it should come up and say start number must be a number. Makes sense. Otherwise, if the start number that we put in there, if it was less than 1 or if it was greater than 10,000, we should put a message in that says start number dot valid range. So this says start number less than or equal to 1 or greater than 10,000. Or less than 1 or greater than 10,000. It'll say this. It must be there. We're putting in that error message. Then we do the same exact thing for the stop number. If we get down to here and we've got any kind of errors, what we want to do is we want to push them back to the page they were on. So we're not allowing them to go on. So this is going to set them back to the index page. All right. So you'll notice when we do this, when I run this, notice I'm on display results here because it worked. But I want to come in here and put in something that's invalid. All right. So I'm going to put in here -3. And I'm going to put in here -4. And I'm going to click calculate. And you'll notice, it doesn't show it, but it actually has pushed me back to the index page. All right, so I'm going to come back here and again put in invalid values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're both too big. Calculate. All right, notice it gave me the numbers, but it has pushed me back to my original page and the numbers are in there. So if I come back here and say I want to go from 11 to 111, for example, there it is. All right. So this does the flip, if there had to be a flip, by using the temp variable. This is going to fill up either the prime array or the non-prime array. So this is going to call a function that's over here in my functions file that's called isPrime. And if the number, if it's true, if it returns that it is true, that means it's a prime number. So I'm going to push it or put it on the end of my primes array. If it returned false, it's not a prime number. So I'm going to push it or put it in my non-prime array. Then again, I just come down here and I show the original form. I'm sorry, this is the answer right here. So this says start number, stop number, prime numbers, etc. I really should have had one more break tag in here. I don't even know why I put on those slashes, because they're not needed. All right, but I think that'll look a little bit better now, to be honest with you. Okay, so let's run it one more time. 1, let's just do 25. So think about this. What should be the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, 23. Those 9 numbers should be prime, and the other 16 should not be prime. So there's my 9 numbers, 2, 3, 5, 7, 11, 13, 19, and 23. And there's my non-primes. Remember, no even number can be prime. All right, any number that ends with 5 cannot be prime. Okay, just a couple of rules, so to speak, for you. So to show you that file, and again, I've keyed these in twice already, and I don't really feel like keying it in again while you watch and tape that. So I'll leave this up here for about 30 seconds. Again, this is the display results.php file. If you're interested in this, you'll have to pause the tape, type a little, unpause it, type a little more, etc., etc. So next we go down, we're checking, we're only doing the stuff that's in this whole thing if the user pressed the submit button. So that's everything between lines 31 and 96. All right, so the next thing we do here is we validate our start number and we validate our stop number. Again, this code here, these approximately 10 lines here, and these approximately 10 lines here are identical, except these say start number and these say stop number. Other than that, they are identical. So I used a lot of copy and paste here. Then I said if there was an error message, I wanted to basically go back to my home page and just get the heck out. Finally, I had to come in here and see whether or not I had to flip the values. Play computer for a second. All right, let's suppose for a second that we put this information in. I'm going to cut this way down just so you can see it. All right, so I've right now I set temp number equal to 0 up on the top of the program. So right now, let's assume, so we've got $start number, we've got $stop number, and we've got $temp. So when we first start, let's suppose we put in 25 for our start number, and we put in 1 for our stop number. And this is still equal to 0. All right, so let's play math. Do the math. Is start number greater than stop number? Is 25 greater than 1? Yes, it is. So take start, whatever was in start number, and assign that to temp. Well, what was in start number was 25, so we're going to copy that over to temp. So this now has 25 in it. Take whatever was in, take whatever was in stop number and copy it over to start number. So right now we want to take that 1 and copy that over here. So right now they both equal 1. Then finally take what was in temp, which is the 25, and copy that into stop number. So when we get done, we have in essence flipped the values. All right? Then this says, calculate all the primes and non-primes. So start with a start number, go until you reach the stop number, add 1 every time. For each number you have in there, call the function isPrime. If isPrime returns true, push that number onto the primes array. If it returns false, push that number onto the non-primes array. And then here was where we printed our output. So I'll put that up here also. Right? Unfortunately, the only thing you can't see in here, there's 2 lines after this, the ending body and the ending HTML tag. Everything else you can see when you take a look in here. So I'll leave that up there for a minute. This is going to print out the output. So I'll leave that up for about 30 seconds. Then I'm going to take a couple of minutes and go over the functions.php file. And after I get done with that, I'm going to stop, and then I'll start another tape in which I will go over the leap year program. So again, there's all the stuff where we're printing the output, and there's just the body and the HTML. So the only one I didn't go over was the functions page. And it looks like a lot, but it's 40 lines of code. And think about this. It said in our requirements, if the number was 1, it's not prime. So just checking if the number is 1, return false. If the number is 2, it is prime. So if it's 2, return true. So this is, these lines right here, these approximately 10 lines or so, are just to check the numbers 1 and 2. This right here says if we've got any number, whoops, I didn't want to do that. If we have any number here that's divisible by 2, well, it can't be prime because it's divisible by 2. So just return false. So this is going to handle the first approximately 25 lines of this program, other than the function and the PHP tag, are going to handle the number 1, the number 2, and any even number. So if we get down to here, which is the rest of this, this is going to check only odd numbers that are greater than 1. All right, so we start with 3, and we go up to the square root of the number we're checking. We add 2 to it every time. And we keep going through here, and we say if the number is evenly divisible by something, return false. If we get all the way through and we haven't done it yet, then return true. So again, play computer. If you're confused by this stuff, just keep playing computer. Let's say we wanted all the primes between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what we want. All right? So that's the number. In this case, it's going to be num. So this is $num. All right. And this is going to be return value. So this is going to be the return. So in other words, it's going to be true or it's going to be false. It's going to be one or the other. So right here, this says if the number is 1, return false. All right, so that one will return false. This one says if the number is 2, return true. So that's true. This says if it's any even number, return false. Well, 4 is an even number. 6 is an even number. 8 is an even number. And 10 is an even number. So from these first approximately 20 lines of the function, we now know that out of our 10 values, 1, 2, 3, 4, 5, 6 of them, we already know their primeness. Okay, so we only have to check 3, 5, 7, and 9. So let's look at each one of those individually by using the algorithm that we have here. All right. So, starting with 3, as long as the number is less than or equal to the square root of 3. So in other words, I only have to check in here 1 and 2. So, does 1 go, 1 doesn't matter. I only have to check 2. Since 3 divided by 2 doesn't go in evenly, that returns true. It's a prime. 5. Start with 3 and go to the square root of the number. Well, the square root of the number is not even 3. So that can't be prime, or that must be prime also. So we come into here, and that's true. 7. What's the square root of 7? It's 2 point something. So again, we're starting at 3, but we're saying, well, it's less than or equal to 2. That has to be prime. So we've now got 9 out of our 10 done. So we're up to 9. Start with 3. Go to the square root of that, which is 3. All right. So from 3 to 3, we only have to check once. If the number 9 is divisible by 3, and it is, return false. So that one can't be prime. So that's false. And if we kept going, you'd be just doing the same thing every single time. So again, I'll spend about I'll leave that up here for about 30 seconds, and then I'll go down to the bottom of the program and leave that up there for about 30 seconds. So again, what you see on your screen now is handling the number 1, the number 2, and any even number. All right, then we come down here to the bottom. I'm just going to hit enter a few times just so you can see all of it on the screen. You already saw the output of this, so ideally at least you now have enough information, all right, that you'd be able to finish this problem. So again, this was number 1 or number 2, the prime number. Okay? If you want to be able to get the maximum points possible for this, I didn't print it out as a table. You should. The number of numbers read, the number of primes, the number of non-primes, etc. All right? So you follow those if you want to be able to get the maximum points possible. The next question here was number 3. And it was on a leap year. I'm not going to read a bit of this to you. All right? But what we were supposed to do was, again, it's very similar to the prime number program. We were supposed to enter a start number and a stop number. And then figure out the list of prime numbers in between those two. So what I ended up doing, just as an FYI for you, what I ended up doing, and I'm not even going to save it. I can save it. But I'm going to close all of this stuff. Sure, I think it matters. All right. What I ended up doing for the second problem in here, here's the leap year. Here's my CSS file. It should look doggone familiar to you because it's the exact same CSS file. Exactly the same as in the other program. All right? So let's look at the three. What I ended up doing was literally copying over. I did the prime number one first and then copied it to leap year. I just copied it to another folder. Why? Because there are a boatload of similarities here. Here's our index. Here I am again including my functions.php file. I again have about 20 lines full of comments, 20 or 25 lines. This is set up exactly the same way that the other one was. So you'll notice with this one, and I'll come back to this in just a second, but if I change this from prime numbers to leap year, all right, well, I should have started with the index page, not with the display results page. All right, same kind of thing. If I put in 1 and 100. Let's play computer for a second here. Leap years occur every 4 years, right? So what should print here is 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, 80, 84, 88, 92, 96. Is 100 a leap year? Remember, for a year to be a leap year, it has to be divisible by both 100 and 400. 100 is divisible by 100, but not by 400. So it should have just all those up to, but not including 100. And there we have them. 4, 8, 12, 16, etc. So those are our 24 leap years. Here are our 76 non-leap years. 1, 2, 3, 5, etc. all the way through and including 100. So again, I tried to give you an assignment that was virtually identical between two of the problems that were in here. All right? It wasn't done this way accidentally. So I'll leave this up here for a minute because this is the explanation of the index for the leap year. I suppose that what I really should have done is I should have stopped here and started another tape. In fact, I'll do that and I'll come back to this. Okay?